Okay, so good morning everyone. Senan on this side, and in this video we are going to solve this LeetCode daily problem, magic squares in grid. So you would be given a grid of numbers, integers, and you need to find a 3x3 magic square. So what is a magic square? Magic square is a 3x3, in this case 3x3 matrix, submatrix in this case, in which the sum of all diagonals is same and the sum of all the rows are same, sum of all the columns are same. Or basically, let's say all the diagonals add up to the same number, same with the rows and same with the columns. And so we need to find the magic square. Now the constraint is the grid may contain numbers up to 50. If you see the constraints, you see grid can have 0 and numbers less than 15 as well. Okay, so you see the row and col is quite small, so the only thing I could actually think of is the brute force approach, right? And what we need to keep in mind is that this magic square also has distinct numbers from 1 to 9. So we cannot have repeated elements as such. So somehow we need to keep track. Now what I'm planning is to do a iteration of this grid from I, j using 2 iterators, and at every I and j I'll check the submatrix, the remaining 3x3 matrix starting from that I, j. Let's say if I start at 5, my submatrix should be 5, 1, 9, 7, 6, 2, but we needed one more row which is not there. If we can only go from 4 to 6, this submatrix. And yeah, let's first of all see how I would approach this question, and we will understand while writing the question itself. So okay, I need what? I need rows and columns of this grid, right? Int rows is equal to grid dot size, and columns would be what? Grid of zeros. Now I need to traverse the whole matrix, so I would do that for int I is equal to 0, I less than rows minus 2, I plus plus, for int j is equal to 0, j less than cols minus 2, j plus plus. And okay, so before going ahead, rows minus 2 and cols minus 2, because if let's say how many rows are there in this? There are 3 rows and 4 columns, so rows minus 2 is what? 1, right? And cols minus 2 is what? 2. So at max in this iteration we can only traverse in 4 and 3, because if we go any index other than this 4 and 3, there won't be a valid 3x3 matrix starting from that index, right? So that is why we decrement this by 2 to check there exists 2 more rows and 2 more columns from the starting position. Now I will call this function if valid magic matrix, and I need to pass the grid and row and column. If this is true, what I would do is I'll say count plus plus, and I did not declare count, so count is equal to 0. After this I return count. Okay, so the only thing is we don't know how to write this, so let's write that. So it would be a boolean function if valid matrix, and we would pass the grid, the row the column, the starting row and the starting column. So first of all, we need to see if we need to check a couple of things. We need to check uniqueness, we need to check the sum. So first of all, I would go by checking the diagonals. So let's declare two variables. Int diag1 is 0, similarly diag2 is 0. Also, I would keep a track of let's say a check size 10 with initialized values as false. Okay, so whenever I encounter some element, I would set that element as true to keep track that I have already seen this element, right? And I'm storing this in a vector because it would be, or an array, because it would be a constant time lookup. Okay, so first let's check the first diagonal. That means going from top left to bottom right. And I is equal to 0, I less than 3, and I plus plus, and diag 1 plus equal to what? Let's call this int lm is equal to grid of what? Row plus I and col plus I and lm. Okay, this would do the job, but let's write something known as a lambda function. Auto within meaning the element that I see is within the possible range and I have not already seen that element. So within is equal to, so what it has access to is the check vector, and it would take an argument of the element, and the return type is bool. So if lm is less than 1 or lm is greater than 9, that means this element is out of bounds, so I return false. Otherwise, if check of lm, that means I have already seen this element before, right? Again, I return false because I need to ensure uniqueness of all the 9 elements. If that is not the case, I would say that I have seen this element, set this as true, and I return true as well. Okay, so since I have seen this element, what I do is I say if it is not within, right? If this element is not within the ranges and I have also not seen this before, what I do is return false, because if this if statement is true only if when within is false. When within is false, so there are two cases where either they are beyond the limits of 0 to 9 or I have already seen that element, right? In that case, I would return false. Okay, now I would do the same thing for diagonal 2 as well. Diagonal 2, and but the only thing different would be I need 2 iterators, right? And j minus minus, col plus j, row plus I, and this in this way we would be able to traverse the matrix like this from top right to bottom left and add row plus I starts from 0, or okay, so I would let this be j and this be I. Okay, so did I do some mistake? Hey, no. Yeah. This was fine, right? So first row I0 and j is 2. Then if we go one step ahead, row increment and column decremented, so we reach here, Again, if we increase the row and decrease the column, we reach here, right? Okay, so now what is the problem with this approach? Currently there is not any, but let's say if I see all the unique elements in the first diagonal and I go on to check the second diagonal, right? So since I've already seen 5 before the middle element, I would set this as true. Now since I've set this as true and I traverse the second diagonal, I would reach this 5 and declare this as, since this is true, that means I've already seen this element. So I would return what? I would return false. And if I return false, I would just get out of this function and return false, which should not be the case because we are seeing the same element at the same position. So before going that, I would do is I would set check of what? Check of grid of what? Row plus 1 and column plus 1 as false, saying that I have not seen the middle element previously. So this would do the second diagonal and the first diagonal check. After that, I check if diag1 is not equal to diag2. Then again I return false because the sum is not the same of the diagonals. And now what we do is we check all the rows and cols. So for that I need two for loops. So int I is equal to 0, I less than 3, and I plus plus. For int j is equal to 0, j less than 3, and j plus plus. So what would be the element? Int lm is equal to what? Grid of I and j, and int row sum is equal to 0, and I would do is row sum plus equal to lm. But I need to again keep track if this element is within range. If not within lm, so this would be row plus I and col plus j. So if it is not within, return false, right? And again after this, summing all the elements of the row, if row sum is not equal to diag1, so as of this line, if we reach this line, we know that diag1 is equal to diag2 and there are no repeated elements, right? So if row sum is not equal to diagonal 1, again I return false. And one more thing, before going into this check, I need to initialize the check as vector bool 10, false. Since as we have already seen some elements of this matrix, some of the check variables would be declared as true, and if we go within this function, that would cause it to return false. So okay, that is good. Similarly, I need to check for column sum as well. So I'll just change this to col and col, and just for the sake of using diagonal 2 as well, so I can write this as diagonal 2. But since diagonal 1 is diagonal 2, there is actually no need. But the only thing that would be differing here is the iterators. So this would be j and this would be I. Why? Because if for any column I fix the column and traverse through all the elements in the vertical order, right? So I would be traversing the rows, keeping the column as fixed. So yep, if that is the case, if it is all true, I just return true. See, I just did this problem a while back, so you see the problem is accepted. Let us see if this is working right now, or am I missing something? Okay, so this is accepted. Let's just submit this and then we'll discuss the time and space complexity. Okay, so accepted. Fine. Okay, so if you go in this function, you see the time complexity for this is rows times columns, big of rows times columns, and yep, you call this function once, right, inside this. So what is this doing? It is going through all the elements, all the 9 elements, and the operations are constant regardless of the size of the input, because this whole matrix is working on only 9 elements regardless of the row times columns size, right? So this would be running in big O of constant time, or big O of one time, or constant time, as well as right, we are using a space of big O of 10, which is same as big O of constant, right? So the overall time complexity would be the size of the grid, and the space complexity would be a constant size. Yeah, and I don't know if I mentioned this, I used 10 for using 1 based indexing, right? So if element is from 1 to 9, I set the value at that checkpoint as 1 to 9. That is all for the video, guys. Hope you enjoyed this. Hope you learned something from this. If yes, please share it with someone who you think this might be useful, and keep working. Bye.